Okay, it's 8 o'clock in the morning. Good morning, everyone, and thank you for joining us on our last webinar of the year. Today, we'll discuss about Philippine textiles research and development and innovation to the new future. Our speaker is a registered chemist, and he obtained his bachelor and master's degrees in chemistry from the University of the Philippines, Diliman. He did his master's thesis on mechanical heterogeneous catalysis in Academia Sinica in Taipei, Taiwan, under the Meco-Teco bilateral cooperation. He obtained his PhD in chemistry, nanoscience, and technology on solid-state inorganic luminescent materials from the National Taiwan University in Taipei under the Taiwan International Graduate Program. He is currently the Chief Science Research Specialist of the Research and Development Division, Philippine Textile Research Institute, Department of Science and Technology, where he has been with in the last 18 years. Let us all welcome our speaker, Dr. Julius Leano Jr.
Good morning, everyone.
Good morning.
I'll share my screen now. Does it come out clear?
Okay. Yes, it looks good.
Sure. Okay, good morning. This is not maybe our typical scientific talk, because I'll try to make it as magazine and as inclusive as possible. But technically, this is the Philippine Textiles R&D and Innovation in the New Future. And I'll be defining later on why we have to use new future rather than the usual new normal. So we are beset by the scenario by which we have an $180 million Philippine textile export. This is an aggregate of fibers, garments, and textiles if we have. However, if you look at the imports that the Philippines is getting, it's about 1.2 billion, which doesn't really make sense. So there's some discontinuity in all these things happening. And yeah, one for sure, we could highlight that 43% of all this going out really goes to the US. So this maybe is a remnant of the MFA in the 90s and just maybe keeping the industry afloat, if you want to call it that way. But the downward trend in either textiles or garments, in manufacturing output, for example, in value, at the same time in employment, really is very unsettling. So this is part of the road mapping that was done by the Board of Investment with the DTI, and this basically led and predicated the initiatives that we have in textiles. So if you see this graph, basically the one at the bottom is production. This is your CMT, if you want to call it. On the garment side, this is your cut, make, and trim. How very, I don't know what word you would describe it as. CMT is just making it, cutting it, and trimming it. And that basically is the bulk of textile production. Now, the only way by which we could add economic value to this is if we move upwards, at least in upwards. So either you go all the way to moving to the pre-production intangible interventions, or even in the post-production. Either way, we don't have any of that oscillation. So that's why we are just here sitting in the middle. And this is the thing that we want to disrupt. Now, these are some of the milestones, short-term and medium-term milestones that were distilled out of this road mapping. And we were just fortunate to see that they were looking at about 5 to 10% increase in natural and synthetic fiber availability, or maybe production, or maybe processing in the local scene. And this basically is an agriculturally dependent intervention. The second one is in the medium term. And we are quite fortunate that finally, from the side of the DTI, have highlighted an increase in R&D investment. DTI does sit down, and the DTI is the Department of Trade and Industry. They do sit down in the governing councils of the DOST. So basically, they also have a say in how to steer and direct and maybe focus R&D investment in textiles and garments. So yeah, there's been a resurgence of all these Philippine textiles. Of course, this is beautiful, right? Not only the wear, but the fabric. But if you'd like to see it this way, yes, it becomes costumey. It becomes a little, there's a certain level of awareness. But during the pandemic, things have been exposed. And that means that the Philippines could just not yet clothe its own people, let alone protect them. And this is quite sad, because if we look back, there are still just, tatlo pa rin yung ating, we still have three basic needs: food, shelter and Wi-Fi. Third is still clothing. So we still stick into that, and we still have 100 and more than 100 million Filipinos to clothe. And this is the battle cry by which the Philippine Textile Institute comes in, proposing interventions by which we could make ourselves self-reliant in not only in textile production but also in garments. So again, yeah, new normal. So new has been used repeatedly. This is basically anything that is not now. So we're looking at the future. But the new normal previously is just an unfamiliar field, an atypical situation that we want to conquer. So if a new normal, I don't see anything exciting with it. Rather, we'd want to look at it as a new future, because the future alludes some prospects of success and happiness. And this is it is a disposition that we want not only our upcoming and ongoing R&Ds, but also our interventions to look into. So there's a sense of direction, and this is not a matter of adjusting to what is given to us, but actually creating the future for us. At the DOST, we have 7 research and development institutions, and one of them is Textiles. That's where I belong. And particularly, we're working with natural textiles, natural dyes, smart textiles, and a lot more. So product development has come in recently, digitization has come in, textile conservation, even some policy interventions, and they all fall under the ambit of our mandate. So if we look at textiles R&D, or at least in the material development side, we are looking at fibers, and these are your man-made fibers and synthetic fibers. And yes, not to preempt, but in the Philippines, we're basically looking at the natural fibers, because this is where it's most abundant and most relevant. We also have the dyes. This is the one that goes into your fabric, making it colorful and appealing. And lastly, the finishes. This is where you put the functionality in these materials. Now, this is just a textile 101 thing, just to put us all in perspective. So a woven material, you have a parallel yarns, and then you have your perpendicular yarns. That's basically the woven. The knits are quite different. You don't have parallel or perpendicular lines. And the non-wovens are even more free, because this is basically the interlacing of fibers. So these textile assemblies are also the arbiters or the renditions of materials by which we work on. Now, the textile manufacturing basically starts with fibers, and fibers are spun. And if I say spinning, it's as though it's very simple, but it is a wide, long range of machines that eventually converts your very short staples or very short fibers into a long continuous yarns used for weaving, for knitting. And then you have your fibers being directly made into non-woven processing, particularly not needle punching, as in this case, or maybe wet laying, or in some other situations, we will counter the spun lathes techniques. However, what makes this very distinct, the textile manufacturing continuum, is the ability of the Philippines to be able to turn around textile materials from the ground. And I'm looking at agricultural byproducts, say abaca, pseudostems, for example, or pineapple. Do you know that a banana, for example, once they bear fruit, they will not bear any fruit again? So that's why in the farm, they would have to cut it down, and then it's allowed to rot. If not, they are allowed to, they're incorporated for fertilizer purposes. Similar with pineapple, there's a certain time by which they would cut it down, and the leaves basically become part and integrated in the soil. And this is where we come in, because we put value on top, of course, of these byproducts. We still have our fiber crops, abaca, and some other minor products like rami, saluyot, and some other, and water hyacinth even. Now, the finishing of these fabrics, if I move forward, would lead us to the different renditions of all this materials. So in PTRI, we have always been constrained by looking at it for just the wearables. But just recently, maybe about 5 to 10 years ago, we have expanded and tried to conquer a part of this textile manufacturing that's not most widely used or widely exploited in the Philippines. Is non-woven processing. That goes for the geotextiles, that goes into your roads and civil works, even for shoes, even for the nappies, and of course the typical wearables, bed linens, and home textiles. So textiles R&D is basically on materials, on colorants, finishes, machines, processes, and systems. So I'll look this magazine show back in this slide, as we will try to summarize it in the end. But basically, this is about materials, the colorants, and the finishes. And because of this, it predicates the PTRI R&D program. So we have 7. One of is on the green materials, the others in nanotechnology. For example, we're about to repackage our textile nanotechnology R&D, our smart textiles, our textile biopolymers. This is where we will have to make some of the materials available again, abundantly available from the field, and convert them into textile raw materials, the Philippine silk R&D, and product development. So for just to put semblance of science into this, the textile fiber, if you zoom in, is basically composed of our cellulose fibrils. But in the cellulose fibrils, there's a glue that puts them together, and you call them the hemicelluloses, and pectin, which basically adds that distinct brownish color into it. So the target is, first, how do you liberate this material? How do you liberate these fibrils from the source? I mean from the plant, and how do you in turn further liberate the microfibers from those that binds it together? So there are different techniques. I just have listed some. On the mechanical side, and this happens primarily in the ground, we have stripping. This is the one they do with abaca, and decortication, when you remove the middle lamella and the parts of the leaves and pseudostems in order to liberate the fibers. And consequently, it goes into a chemical process, sometimes retting, sometimes a caustic soda-based technique, or as what we have done and demonstrated recently, the use of enzymes to make it more less invasive to the environment. So this technically is the heart of the R&D in fibers. How do you liberate the material from the ground, and how do you further process it, not to become pulp, because the extreme is when it becomes pulp and that you use that for paper. Paper technically is not textile material anymore. But how do you move in the middle in order for you to still get the integrity of the fibers, and be able to spin them into yarns? So this is a simplification, an oversimplification of how raw fibers are transformed into yarns. We have here the raw fiber. I think this is abaca, and particularly this mandala. This is the new hybrid that, no, not hybrid. This is a new variety that was developed by the Institute of Plant Breeding in UP Los Baños that is actually resistant to the virus, yung Sabanchi top virus that plagues the abaca industry. So we have the raw fibers. Technologies are in the middle before you get into the treated fibers. We open the fibers, and this is a mechanical opening, rendering them into a cottonized version before they get into your gray yarns. So the yarns doesn't look very appealing at this point, but technically this is how they look like when they come out from the mill, and then further finishing would render them into the quality of the yarns that you use for weaving. So let me welcome you to the Philippine Natural Textiles Development. Basically, again, on fibers, making them into ropes and slivers all the way to the yarns, and of course to weaving and to knitting. Now, natural textile fiber transformation starts from the source, and the PTRI patented technology is in the middle. It's where the textile fibers are converted in a form not too much that it becomes pulp, but not too mild that it remains as a stiff fiber, but to a point that it could actually be spun, meaning you could put it and feed it into your usual spinning lines. And this is where our patented technology is on abaca, banana, pineapple, and some other minor fibers. So in fiber pretreatment, the lookout is fiber length. Do we have a sufficient fiber length? Because it dictates which machines will be used for spinning. And the fiber fineness, because that actually predicates the difference. There's a certain difference in the fiber fineness of the carrier yarn, of the carrier staple, and the natural textile fiber. So we would want to approach the fineness of the carrier yarns, and the whiteness, of course, and tenacity. So this is one of our recent developments on bamboo. So we have used, I think this is Kawayang Tinik, because Kawayang Tinik is the most abundant in the countryside, although it is not a local, it is not endemic to us, but it is most abundant. Economically, the fiber recovery is about 35%, which is quite high. To compare, abaca is only 1%. So this is quite a very good source of raw material. You can see how it actually transformed. The secretary of the DOST was one of our first model, because he already used this in one of our events in 2019. And we are already plotting, and I will show you later on, the nationwide scope for the deployment of this technology. This is a patented technology under the conversion of these fibers into fabrics. So just to give you a perspective, when you sell the poles of bamboo, it's basically 5 kilos per kilogram, and you're selling it maybe about 100 peso per pole. When you convert it into pulp, the value per kilo becomes about 60 pesos. When you do the wood panels for the engineering works, the value would go up to about 291. However, lo and behold, when you do it for textile manufacturing, per kilo of fiber technically becomes 1,179. And the question is not really in the value transformation. The lookout of PTRI is, where does this value transformation happen? And the philosophy, the paradigm, and the belief of the institute is that this material transformation must happen as much as possible in the communities. So we also lock the income, we lock the benefits of this technology with the communities. And we've always been talking about farmers, community development, etc. This is a real thing because we have designed the technology to be adaptable to community level manufacturing. So where is this leading into? The first one is, of course, enabling a law that has been passed in the mid-2000s. This is the Republic Act 9242, mandating at least 1.8 government employees to use our locally made fabrics. And they're not talking about your hand-loom woven fabrics only. We're talking about anything that is spun and manufactured in the Philippines. And mind you, this industry, or this by itself, is already about 10.8 billion, considering that we have about 6,000 peso per employee for their uniform allowance per year. So the implication is not only in raw material mobilization, but all the way to garment manufacturing. So the entire value chain is actually being mobilized. So the wisdom of the law is basically to revive and to revitalize activities from the ground all the way to consumption. And just recently, we were also approached by Picard because, as I mentioned, in the fiber that was developed by UPIPB, is how do we actually make now our own local protective wear in order for us to have, hindi ito yung disposable. These are not your one-time use. We want to make, at the start, hindi naman lahat were disposable. So what we wanted to do is to get hold of that, because we are not actually, the hospitals will keep on operating. And what we want is that not only for the uniforms that you use in the offices, but also for functional textiles that you could use in hospital settings, for example. And hence, we have conceived the rewear suits. This is actually the version 2, because we will discuss rewear mask later on. And this basically uses our local fibers, converting them into functional wear. And this is part of the PROTEX program. PROTEX means Protective, Re-engineered, Occupational Technical Textiles. This is a banner program of the Institute targeting functional textiles. So, which materials have we worked on? These are the yarn blends that we have in the Institute. We have basically worked on cotton, lyocell, this is regenerated cellulose, and silk. And maybe 10, 20 years ago, we've been working with polyester as well. We blend them with pineapple leaf, abaca, banana, water hyacinth, saluyot, rami, and so many other minor fibers. And the target is that it becomes all natural. By all natural, we already have succeeded because lyocell is technically biodegradable. And percentage composition in the yarns is that there must be at least 40% of all these natural textile fibers, and that they are compliant to industry standards, whether they're used for uniforms, for home textiles, or for protective wear. So this is the map that I was showing you about. This is bamboo, and we already have mapped out our activities until 2025 and the rollout of the technology from Abra all the way to Bukidnon. They have been strategically identified, and we will find out later on why these places were selected. It's not just a matter of the abundance of bamboo is everywhere, but also the strategic position of these facilities. Also, the innovation map for the other different fibers have been identified. You would be surprised that in Apayao, they are growing abaca, they have pineapple, and they have banana. And Apayao is one of the less rated among the provinces in terms of their participation in textile manufacturing. So we also have laden down here to provide, a superimposition of all these engagements. And the innovation map, this is RIPIC. RIPIC is the Regional Yarn Production and Innovation Center. So it's not enough that we have the yarns. We have to convert, fibers. We have to convert them into yarns. That's why we also have strategically positioned these RIPICs, or these Yarn Production Innovation Centers, in Isabela, in Cavite, in Iloilo, which is already operating now, in Negros Occidental, and in Davao. And if you put them all together, this is how it looks like. So basically, you're covering from Luzon all the way to Mindanao. And what is interesting about this map is, let me just highlight that we have at our demo and pilot facilities for the bamboo technologies in Maragondon, Cavite, and in La Union, Nagilian, La Union, happening next year, because we already got funds for that, in order for us to verify the technology and be able to engage the communities and test the model by which the one I mentioned earlier, by which we lock material transformation and value transformation in the community level. So aside from the wovens, let me move very fast to the non-wovens. We also have developed non-woven applications, basically needle punching applications of all these fibers in blend with cotton or and even with polyester. So the application is wide. It could be your bed mattresses and linings. It could be your wall, anti-acoustic wall panels. It could be filters. So this non-woven textiles R&D program was a 2-year in the making program, but fortunately we already got funded, and we'll have the pilot facility up and running in the institute, and we have partnered with a private company on the needle punching machines somewhere here in I think in Marikina QC area for the development, upscale development of these non-woven applications. They're itching to get hold of these materials, and we're also looking at the car furnishings for this one. That's why we're also working with another affiliate agent, an affiliate institution for the development of the more rigid applications of these non-movements. And during the lockdown, as I was telling Kay earlier during our chit chat before the talk, we have been, well, chances are you have to innovate, and some of the quick low hanging turnarounds were the disinfecting mats. So how good is it that you use it for a certain period of time, and when you throw it, you don't have any problems about biodegradability. So we were able to push numbers and the use of abaca, pineapple, and banana. It was best to use banana because it's one of the underutilized fibers. But again, disinfecting mats would just be one of the so many applications for this material. And also during the lockdown, we went into the filter technologies where our wet laid applications, where it was able to render our fibers into the wet laid non-woven textiles. And we were looking at the substitute filters for mask and even for our air conditioning panels. The only limitation that we got here is we had to focus on our other project, and we are now waiting for this test to turn around. So aside from this physical assembly of the fiber, as I mentioned earlier, we also have non-woven technologies, and this will be up by 2022. We already have started talking to JG Summit. There's a non-woven manufacturing locally. There's also ChemRes DNL on the supply of the resins and raw materials. The idea is, how do we now make our single-use non-wovens more sustainable? Second, how protective wear? How do we level it up in such a way that we could actually own it? The self-sufficiency philosophy is still there, and challenge is still there, and good enough that there is investment. There's a huge private sector interest going into this, and the talks that we have just yesterday is that we're already having one quick cradle project in the DOST by first, maybe second quarter of next year, particularly in the blending of the more sustainable fiber raw materials and some recycled petrochemicals. No, so it's a melt-blown spun-bonded technology. This is something that will not necessarily yet just with us, but it will be happening in the future. But if you see, non-wovens span a lot of commodities. It could be for your tea bags, for agriculture, even for energy applications, even for our civil works, etc. So this is the one that we would want to capture and position PTRI in the middle as an R&D institution for non-wovens manufacturing and non-wovens research and development. And the interest of not only of the private sector, but also other government agencies to be able to position R&D in the heart of all these developments is really just very encouraging. Now, just this year, we were able to complete as well. This is still technically non-woven, but it's the electrospun side. That's why we are in the nano dimension. So we have already synthesized cellulose acetate earlier on from our fibers, but we have also electrospun them for different applications. But just recently, we have electrospun them in such a way that we can actually load some drugs or some antiseptics into it that could be directed for wound healing applications. So this is these are already assays that we have conducted just this year. The top picture where we had the rabbit samples here is a comparison of the cotton-based cellulose acetate electrospun fibers versus the banana electrospun cellulose acetate derived fibers. And basically, we see here the comparison of the rare wound healing efficacies. And in the bottom line, at the bottom side, is you could see the assays, the wound healing assays, by which we correlate epithelial growth with the wound healing application. So we were able to get this data this year, and we are scaling it up with a PCHRD proposal for 2022. So the idea basically is, how do we use all these natural materials in order for them to serve purposes that cuts across human needs? Now, for textiles that are just meant to cover the things that you don't want to show, they basically are part of your conventional textiles development. But then we have smart textiles development, and this is where our finishes are being localized. So the question is, don't we have them already commercially available? Yes, we have them, but there are some peculiarities, uniqueness of all our materials, the materials that we have here, including their processing, that allows us to, to move a little bit more, a little bit more creatively on the smart textiles development. The first among those that we have developed, and this was already about 10 years ago, before I even went for Taiwan, was the water repellent seed. So the question then was, bakit nga naman mong gagawing water repellent yung knitted fabric? Eh, ang Pinoy talagang maglalabayan. You don't expect a Filipino, or you don't expect somebody not to wash their clothes. So it kind of was shelved a bit at that time, because we couldn't find just yet the application. But no, lo and behold, during the pandemic, it got a big boost. You know why? Because we used it for our rewear mask. So for rewear mask, you want the outer layer to be water repellent. You want the inside layer to be at least, not water repellent, so that it could absorb the moisture from your breath. The outer layer becoming also breathable. So that's why we use knitted fabrics. And this is the rewear development. I hope you were able to chance upon this one in the media. But basically, it featured already our smart textile technologies, and it could stand 50 hand washings. The curved shape is compliant with WHO. It's cleared for the test in skin sensitivity and cytotoxicity. It's breathable based on the WHO standards. You have a washable inner layer. The content of the fibers here, the cotton, is about 50% or more, and we have the rewear certification tag, which, by the way, is another intellectual property that we are enforcing for the development of community use face mask. So this is how it works. So basically, it's a straightforward thing, but this technology is based on the silanol science, or silanol assembly on the fabric surfaces. And the catch is, it has to be deployable, meaning you don't have to reinvent the industry that has to accept this one. So you have an existing industry, so we had to develop the formulation, and develop the application parameters in order for it to adapt to the upscale application. And I am proud to also let you know that out of this project, which we did during the worst times of the lockdown, 500,000 beneficiaries has already been served, because we have been rolling them out since May of this year. So aside from the water repellent system, we also have the controlled release system. The controlled release system was inspired when, during the Yolanda time, there was such a stinky smell during that time. There was mosquito, etc., etc. And we were asked by the DOST, what can we deploy immediately in Yolanda? And then came this project. Well, we were already done with this project, and we were able to deploy not only the scent-infused textiles, meaning just to make the environment a little more pleasing, but also the mosquito repellent textiles. And this was also done in collaboration with Akaba. If you know this bag brand, this is also a startup. Akaba infused mosquito repellent finishing on their bag tags. That's why it renders the bag also mosquito repellent. So this is one realm by which we exploited beta cyclone extreme, serving as a basket of a myriad of functional materials that could be used for this application. And if the basket is empty, then it could also be used for odor trapping applications, having a lot of possible permutations in the hospitality industry. Also, the self-cleaning, this was completed about 5 years ago. This is the assembly of a photocatalytic system on top of the textile material. So it's a zinc oxide, titanium dioxide nanocomposite that basically, when you have a stain, or this stain could either be dirt or even organic material like wine, etc. And with normal sunlight, even our fluorescent light, it could actually fade. It could actually be destroyed. So this system, of course, is based on the photocatalytic activity of this assembly. And you could see the diagram. I don't know if it comes clear and clean, but in letter D, you would see here that after 15 hours of just exposing it to sunlight, we have a simulated sunlight setup here. You could see the fading, the obvious fading of the stain, and we didn't do anything on this material. So this is still up for development for verification, but we did already run a pilot scale verification with the mill. So quite on a small scale just yet because of the cost of this material, but we're first and foremost developing and refining the photocatalytic system. Now we have also developed the optical security marking. So this is based on a cellulose nanocrystal. So we've been working extensively on cellulose nanocrystals for how robust that material is. So what we did is that we have functionalized the cellulose nanocrystals and here in order for us to infuse functionality. So what we did is that we there was tempo oxidation and then the rendering of it into an alkyne. So if you see an alkyne for organic chemists, you already know that you're about to do a click reaction. And with an alkyne and with an A-side functionalized fluorescent material, we were able to click it and produce a cellulose nanocrystal modified with a fluorescent tag. This is, I think, fluorescein. So how does it look like? This is how it looks like under normal light. This is under in the dark, and this is how it looks like under UV light. Meaning, you cannot see it you cannot see it in the dark, but you can see it when you shine blue light. So how do we find applications for this? This is just not about flexing our our organic chemistry skills, but technically this development is hinged upon the production of a smart material that could be used. So this is how it looks like on yarns when you're not in the dark and not shining blue light. This is how they look like when you shine. This is how they should look like. I mean, because our samples are not included in this slide yet, how it looks like under blue light. And the application is one for anti-counterfeiting. We are looking at our traditional textiles being authenticated. So how would you know that this was actually done by agawad manlilikha ng bayan awardee? So you don't want to be seeing a fabric like tinalak tapos meron siyang yellow marking on the side, right? You don't want to see it that way. However, under covert circumstances, like for example, when you shine blue light on it, you would see either the sides, the merong marking, this is from, by something from Lake Cebu. And this goes to all the other textiles. Also for Philippine and also for our traditional artisans, it will be used for authentication and anti-counterfeiting. Also for Philippine tropical fabrics, kasi mataas yung chance sa nito that it could actually spill out again in the country, and then some other countries would be producing and then exporting back to us that material. So we wanted to authenticate so that the law, the RA that I mentioned earlier, would also be enabled. And lastly, in actual applications, this is just a discussion that we had with DND, the National Defense, where they say, paano mo malalaman pag yung checkpoint mo police talaga? So this could also be used, maybe a markings in their uniforms that when you shine the blue light, maybe you could say, yeah, really he is. And then the footprint or the fingerprint of this one is that the wavelength is very specific. So if you have tuned the fluorescein or the fluorophore to be, say for example, at 525, if you see a 527, then definitely you know that it is not anymore that material. So it will be that specific, it will be that secure, and hopefully we can realize it. So having mentioned about all lignocellulosic fibers and smart textiles, other parts of our interventions for the industries on Philippine silk. So yes, we have silk in the Philippines, and this is extensively done in the Visayas and in Mindanao. This is our center in the Technology Center in Misamis Oriental, up in the mountains of Misamis Oriental. This is just a recently renovated facility, but basically this is already hinged. Before we were just mating the silkworms and then getting the yarns out from them. But what was good about that one is that we were able to profile in the last 20 years the performance of the breeds or the performance of our lines in Philippine setting. However, just recently, 3 years ago, we ventured into the genomics dimension. So we already had identified, profiled the genome of the silkworms that we have in the Philippines, authenticating them to be Philippine silkworms. And they are not anymore silkworms from any other country. So these are Philippine silkworms. There are 87 of them that is lodged in the germplasm of PTRI. And with the silk genomics work that we did with the Philippine Genome Center and the National Institute for Molecular Biology and Biotechnology in Diliman, we did sequencing and bioinformatics on the SNPs, or the single nucleotide polymorphisms in the silkworm, because we were trying to find a way to authenticate and to be able to profile the distinct fingerprints or the distinct genomic characteristics of these ones. Remember, nasa isa ang kanilang species. They're all Bombyx mori. And how do you determine one from the other? So this is part of the study. And we already have identified a silk genomic assisted marker breeding or a marker assisted breeding. So this basically would now direct us to a certain property, a certain characteristic. For example, do you want a long silk filament, or do you want a silk filament that is, for example, lustrous? Then we know already which breeds or which lines are to be mated. This is not anymore dependent on phenotypic characteristic, but already genomically based. So we can use this to now go into transcriptomics and even metagenomics in order for us to do the locational trials on the effect of the abiotic factor. Remember, these were all done in Misamis. We want to duplicate this, for example, in Nueva Ecija. We want to duplicate this in Benguet, as we have also the project in the Cordillera and Silk. So this data or this information must be available to our farmers so that they will be able to be guided for the mating and the mating and the generation of silkworm hybrids for commercial purposes. So, yeah. And these are now the cocoon hubs. This is now the silk production hubs that we have all over the Philippines, rolling out the technology that we have developed on silk. I'm not saying this was developed in the last 10 years. Has been a long engagement of the Institute. And we have now profiled, up and down kasi yung interest on silk, but we now have a very strong presence in Cordillera. About 12.5 hectares of, mulberries have been planted. A reeling facility was also there. So this is another intervention that we have done on the mechanical processing side. So these are all machines that are existing, but we have to adapt them to the local setting. And we have deployed 2 sets, one in Misamis and one in Kalinga, on the microscale silk processing facility. Anong ibig sabihin nun? Ibig sabihin, the cocoons will not travel all the way to Manila to become yarns. They will have to stay in Kalinga. They will have to be processed in Kalinga, and Kalinga should be releasing already the real yarns, meaning the silk yarns. And how best to lock in value transformation again in the community than to do it this way. And now we have 3 reeling facilities all over the Philippines, counted na yung PTRI dyan. We have our throwing facility in Bago City, Negros Occidental, the one we do with Owiska, this is a Japanese NGO, and the silk and dyeing facility. The idea is, with these capacities of these machines, small, these are very small, we are targeting about 272 individual cocoon producers in the rollout of our genomic assisted marker assisted breeding, and targeting to do and to satisfy 48% of the annual silk requirement of the Philippines. It's just very small. We only need 10,000 kilograms of silk. We cannot even produce that. So that is the silk. These silk yarns are the ones being used in the weaving of our barong and pinya materials in Aklan, heavily in Aklan. So these are some of the product developments that were done and rendered on these materials that were developed recently. Technically, these are all rendered in natural dyes. These were all reeled, galing sila sa cocoons from Mindanao. They were all processed and rendered into these final products. Okay, and one interesting just yet again, di ba yung silk yarns, yung silk cocoons natin, nag-spin yan into cocoons nagiging bilog. But what we did is that we did not put intervention to on our agricultural side. They did not put some cocooning frames. So what happened is that the silkworms were allowed to roam around. Pero pag nagro-roam around yung silkworm na yan, hindi naman yan natigil. So they still continue to emit, or to release the filaments. But what happened is that they produce a mat. We call this the biospan silk mat. And the purpose of this was again done during the lockdown. The purpose of this is that it could be used as a filter for face mask. The highlight of this, the property of this one, is that silk has a high surface resistivity. Ibig sabihin may static charge on the surface of silk. And we want to highlight that in order for, without any further intervention, it could be part of your filter package, and it could be used for mask application. We already have succeeded in producing the masks. They are under characterization now. We just have not tested them for the mask assembly yet, but the air filtration and differential pressure performance were all very interesting. They're all part of within the standards for the development of face mask materials. So this is part of our SEDA Pilipinas program. And the SEDA Pilipinas program is basically the Silk Road program. It starts in Apayao and it spans all the way to Mindanao, getting you the interaction of local communities, of farmers, of state universities and colleges, and the coming together of high science and community work in order to realize silk production in the Philippines. And then another animal material is wool. However, this is still coming very soon, and I'll be happy to share with you the results once we get them out from the plant, from the mill. So our fabrics now, we already have our fabrics, but don't you think these are awful in the sense that they are actually very blunt? So this is how these fabrics actually look like in the runway. These are all colored with dyes, and these dyes are all from natural Philippine plants. These are all the natural dyes that we have developed and have rendered on Philippine fabrics. By the way, the fabrics that you see here are all pineapple and silk blends. So close up, this is how they look like. The yellow comes from Kogon, the blue comes from Indigo Fera, and of course, mayroon siyang gold trimmings there just for aesthetic purposes. Bottom line is, these are all derived from nature. So the colorants R&D of PTRIs is in a way organized by this simple diagram. The interaction of light with, of course, the textile. One is that when light shines on the textile material, there's a reflection of light. We're working basically with dyes and pigments in that. If there's an emission, meaning there's a transformation of the light wavelength when it gets into the material, we already have started carbon dots, quantum dots, and my phosphorus research work in Taiwan gets into this part. Here we are looking at the more technical applications already. And hopefully, maybe in the near future, some of us, some could probably help us because we're also looking at the bending of light for the applications for stealth technology and camouflage and some other, national security applications. But basically, I'm already very happy with the first two, as these are, heavily at the chemistry part. So welcome to the colorful world of Philippine natural dyes. Even banana pseudostems, di ba? Nung bata tayo siguro, for me, I grew up in the province, pag niyakap mo yung buko after you drink the water, talagang magmamansa. And that by itself inspires us to do natural dyes R&D and buko, because if it stains, then it could be a dye. So that was the paradigm. Of course, Atsuete and then Kasubha. So natural dyes are defined here. This is a trademark. I'm happy to share that I was the one to design this trademark, basically signifying the 6 basic colors that we could derive from natural dyes. So talisay leaves, these are your huge leaf that you could normally see in wide spaces such as memorial parks. Anato could give us orange. Mayana, Coleus blumei, could give us green, surprisingly. Mahogany bark, and then Indigo Fera species, because we have a lot of Indigo Fera in the Philippines, and Kogon. These are just some of examples. And this is now the complete natural dye palette of all the colors that we were able to develop from Philippine natural dyes, from pinks to browns to blues to the more fancy violets and pinks. And the natural dyes, it's a long story. I want to tell you the details of all these colorants and the peculiarities of all these colorants, but I want to sum it up in this slide by saying that we already have products. So they don't end up as extracts anymore. They have been converted into watercolor paste. They've been converted into powders and to concentrates. Now, these technologies are not actually for hindi namin to binibenta. Technically, this is already part of the public good. So it is already well documented in the books that we have published. I was able to write these books maybe about a decade ago already, documenting the use of these plants for textiles. So they are all here. You could find it here. And then the technologies ranges from, again, liberating the pigment from the source all the way to the powder. And the myriad of applications, textiles, of course, is here. But if you look closely in the picture, you would see it's food and cosmetics. So ibig sabihin, we already have worked also with the Food and Nutrition Research Institute and with the Industrial Technology Development Institute of the DOST, such that our natural dyes, the pigments that we derive from nature, can now be used for food. As we know, it could be used for food and for cosmetics. As they say, di ba? Vanity is next to godliness. So it's a very huge market altogether. So we want to capture that. And this is part of the Natural Dyes R&D program. So this is our experience when we go transferring. As I said, this is already for public good. So we just transferred them through training. This was taken in Ilihan, Bago City, Negros Occidental, up in the Canlaon Mountains. So it's really, tatawid talaga ng bundok at ng ilog to get into the communities. But it's very interesting. This one was taken in Bukidnon. And here, an interesting story is that Crate and Barrel ordered this very long and this long and interesting material that you could see at the bottom of the slide. This is a table runner made of abaca. And do you know who produced and who championed this? This is about 10 weavers. 6 barangays were involved. 3 natural dye colors were used. 14,000 meters of hinabol fabric was developed. About 500,000 peso was derived from this purchase order, and yung mga rejects nila from Crate and Barrel still got an application or use in the local market. And there was a surge by about 50% in the number of active weavers. And this is because of this mother-daughter tandem that we have trained with our technologies in Bukidnon. And we are happy to note that the daughter is already the poster girl of an NGO who also have presented at the Santa Fe, I think it's a fair, arts fair, showcasing the use of natural dyes on their fabrics. So this is how it already has went. Now, in the PTRI, what sustains all these developments is that the Natural Dyes Center, this is the TBI, the Technology Business Incubation, and also the Research and Development Central Facility for Dyes and Colorants. So if there are anything that you would want to be explored or collaboratively work on dyes and colorants, our facility and the Institute already has this, and we're happy to do collaborative R&D with you. So again, this is the range of technologies that we have developed. About 100 natural dye plants have been screened. They have been converted into powders. Some have been done for silk screen printing, top dyeing, compound dyeing. And these are again the books that chronicles all these developments. And I'm happy to share, quite personal in some way, because these colors that we have developed in the Institute is now part of the permanent exhibition at the National Museum. The title is Color Spectrum, Natural Dyes in the Philippines. And I was very happy to see it because I really did not know. And it was picked up. This is part of the Hibla Museum in the 4th floor of the National Museum. And these are my kids about 5 years ago when they were roaming around the museum, and then suddenly they saw my name and they could not believe I was there, and they were saying, "Papa, maybe you have an alter ego," and I said, "No, that's my work." So yeah, this is part of the personal touches and personal gratifications that we sometimes get when our family members and kids see the work that we do. So other than that, ang color natin po nag-iiba. Yung mahogany sa Abra, iba sa mahogany sa Bukidnon. Yung coffee pulp sa Batangas, iba sa coffee pulp sa Baguio. And we have put all these nuances in a natural dyes swatch book and naming system. We have to standardize. Otherwise, hindi magkakaintindihan yung industry. And this is exactly what this project was all about. We have systematically profiled them, got their pseudocolors, processed their colorimetric data, and was able to translate one color formulation from one location to the other, just to shorten it. And then again, some of our technology adapters is the Aklan Pinya Mantra. So if you see some colored fabrics in Aklan, this would probably be some of the natural dyes technologies that we have developed. So these are some of the materials that we have rendered during the Neo-Ethnic Philippine Textiles project, which I also did in about 10 years ago. This is another company, Raquel's Pina Cloth in Aklan, who does dyeing of their own fabrics already using Philippine natural dyes, using the technologies that are disclosed in the book. And these are again some of the materials. As I told you, this is a magazine show, so just bear with me with this. This is how they look like. The black one here is from Talisay. The green one, as I said, is from Mayana. And then the other piles of fabric here, all done with natural dyes. So, yung pinya natin ngayon, hindi po pwedeng pinya lang naman. It has to be embroidered. So this is a barong of the secretary, then secretary, now academician Australia Alabastro. This is a sari manok inspired, and these were all done with silk that was dyed with natural dyes and embroidered in Lumban, Laguna. So we already have also silk material. So ang idea dito is yung dignity ng weaving, dignity ng embroidery. Ang pangit naman pag ang embroidery threads mo ay hindi maganda. So that's why we have to dignify it with Philippine silk and natural dyes. Also with the lace from Santa Barbara, Iloilo, the hablons that could be used for uniform. The small girl here was my daughter 10 years ago. So we also asked her to model for school uniforms just to try to show kaya natin gumawa on a local setting. And again, this is natural dyes. So we also have other companies that have adopted the technology. This is Earth. I think the outlets are in the US and I think in Europe as well. The Higaonan Weavers, who has adopted the technology and silk screen printing. Lake Cebu, South Cotabato. I'll brush through this now because I'm running out of time. These are all rendered. Hindi natin nakikita ang tinalak. This is the tinalak that we know. But we didn't know tinalak that is of these colors. And all these colors are natural dyes. So this is not your invasive, Jobos synthetic dyes. These are all still natural dyes derived from the plants within the vicinity of Lake Cebu, South Cotabato. Nardas, some of you might be familiar with Nardas. They have the Naturals, Nardas Naturals line, all using natural dyes as well in their crafts. Now, indigo dye extraction, I might not have the time, but just to show this is the chemistry by which we extract indigo. The idea is at the first structure here, we have indigo that is bound with a glucose. So the idea of the project that we are implementing this year is that we were able to profile indigo in the plant stage. Ibig sabihin, alam na natin ngayon by using IR equipment, how the indigo already is mature. Kasi ang indication lang namin ng maturity is flowering. But then there would be a more systematic way so that we could also direct the indigo dye production. This is again another experience when we did the technology transfer of indigo in Negros Occidental. And now we have 6 indigo dye powder production communities all over the Philippines using that technology. And they are selling their indigo powder at 7,000 pesos per kilogram. So this is the value of the material that comes out from the community. And of course, 7,000 because there's still a monopoly now of local manufacturers. But this basically is the premium that we could derive from this material. We work with this group in the Mangyans in Mindoro, also using natural dyes for their crafts. So natural dyes is about integration of the players from producers to weavers to the market. It's about upscaling. This was done in Cavite. Ibig sabihin, hindi lang to beaker or calde-caldero. We can now use the existing mills in order to produce the dyeing of the fibers. We have a natural dyes hub in Batangas. It's based in Bawan. They are doing carpets. Ito yung mga carpets na abaka. And they are doing it and rendering it in natural dyes. So how best to do it, but that to do it with natural dyes. And as I said, diversification, because we work with its application for food and some cosmetics. And again, standardization. There has to be a natural dyes code by which color is communicated across commodities and across the different communities. And we are working with that with the DOST project this year. These are the products. We are also with the National Historical Council because we use natural dyes for the restoration of some valuable textiles and the development for digital printing inks. These are now the dye hubs using our technologies deployed all over the Philippines. So again, we have done materials, colorants, and finishes. I've highlighted that. The processes that we do are basically on digitalization for textile product development. We are developing also a sizing system for the Philippines and the documentation of textile weaves for conservation. On the systems, we're basically working on the textile upcycling, circular economy, and even the National Certificate for Handloom Weaving. And the machines, this is a highlight, is the Handloom Weaving Innovation Centers that we have all over the Philippines. And we have one very interesting story. We have developed a Terra loom. This is a loom without a pedal. So this is being now used by those schools with Down syndrome students, and we were able to teach them how to weave and to use these machines. And another part of our work is policy advocacy. We have a pending bill in the Congress on the Handloom Weaving Industry Development Act or Innovation Act, filed by then Senator Legarda, now Deputy Speaker Legarda. So I'm in the last leg now. So Philippine Textiles is about the convergence of science, technology, innovation, the arts, culture, and the environment. So this is what fuels it. And this is part of our banner program, Tela Pilipinas, Textiles Empowering Lives Anew. So the idea is the more colorful the Philippine map is, the more that we have engagement from north to south. And this is the vision not only of the Institute, but all other stakeholders that we share our philosophies with. This is my team, and I'm just so proud to show it to you because this is what fuels those interventions and development that you saw earlier on. This was me during the National Arts Fair. It's a little personal note, but you know, kababalik ko to from Taiwan. And in that fair, pumasok lang kami. You see, ay naka-shorts dyan ako dun because I was on leave. And then I was approached by this Mindanao weavers. Sabi niya, sir, hindi ko sila kilala. But they said they were using natural dyes that we trained them on 10 years ago. And then we also met this group, yung gumawa ng indigo communities. And also saw the small late girl, there is my eldest daughter. And then ito yung weavers akla na sinasabi ko kanina. And then here my wife is with her townmates from Abra kasi nakita niya na, oh, this is from Abra. And then they were doing textiles, and apparently they were also beneficiaries of our handloom weaving. And then again here, Raquel's and India Legaspi, these are our Aklan weavers. And my daughter, who cannot believe that I was able to write a book. What I want to show and close this presentation is that the Philippine Textiles R&D innovation in the near future may be about science. It may be about hardcore science. Maybe in the lab we move north to south, east to west to get these things together. But the idea and what fuels us forward in the near future is that textiles R&D is about touching people's lives. And with that, thank you very much for listening. Magandang umaga po sa inyong lahat.
Thank you very much, Julius, for a very great presentation. I think it's very interesting, and you really showcased what you guys are doing for the textile industry. So I have several questions, and I hope you can still stay
Yes,
on
sure, sure. I
because
will.
I know that you have
I
other
will.
engagements and commitments.
No problem. My pleasure. My pleasure.
Okay, sige. So let's start with a question from Annalyn Salvador here on the chat. So she's asking where can they access all the materials in case they are interested in doing research also for their local weavers that they work with.
I'm not particularly sure if she disclosed where she's from, but I think the best way is for to get in touch with us, please, and we can direct you. We have also our state universities and colleges and partners in the ground, and yeah, they will be able to help and direct you. We cannot be everywhere. PTRI is only in Bicutan, in Misamis Oriental, and some in Cordillera. So if you're somewhere out of those communities, we have partners, and maybe they could work well
Good
with you, very
morning.
closely with
Yeah,
you.
I think. Yes, Giselle, were you saying something? Yes.
Yeah, I'm already in the other chat. So
Okay, yeah,
I
yeah.
just wanted to congratulate Julius, and I
Thank you.
followed his work through with Dr. Celia Lumba. And I'd like to suggest that we look at the model in Indonesia, where batik was
Yeah.
developed at the, you know, decades ago with commitment from the government in different grades or qualities. But they created the market, and they started with government
Yeah. Using it.
employees who would
Yeah.
make use of the batik, which was maybe not the most expensive type, and some had types had natural and also synthetic, composites with it. So I think you have to create the market. I
Yeah.
recall during time of President Estrada, they required government employees to use Filipiniana, but that
Yeah.
is like the style, not the material
Yeah.
itself. My
Yeah.
second comment, Julius, is I do have a cellulase, suite of cellulases from bacteria
Mhm.
from the tamilox of the mangroves. So if you needed, this bacterium to produce very, very potent cellulases, then I would be willing to share this with you from our lab.
Thank you, ma'am.
So
Sure, we will get
I
in
have
touch with
to,
you.
yes, I'll leave now because of the talk of Sec Boy at 9 a.m. Okay,
Apo.
thank
Thank
you,
you very
Julius.
much po.
Congratulations.
Thank you, ma'am. Salamat po.
Thank you
Salamat po.
very much,
Salamat.
Giselle. So yeah, I will post the link here later. So we have so many activities from
I know.
PAASE. So
Oo nga.
after this, we actually have a talk also being organized by Giselle, where Secretary Boy will be speaking. So maybe just a follow up on Annalyn. Annalyn, I think she's from Baguio, if I'm not mistaken. Annalyn, would you like to respond to where your location is?
Hello, good morning. I'm
Good
from
morning.
UP Baguio. I'm with the Cordillera Textiles project.
Sure.
Uh, yeah, we have some of the PTR materials, but we're having difficulty with in terms of access. And
Mhm.
secondly, thank you, Dr. Julius Leano, for sharing this very comprehensive overview of the PTRI project. We are actually unaware that there's a lot of things going on, but we just need to, have the materials to be read by our team and also to share that also with the other local weavers because we are working on the ground with the Cordillera Textile project of UP Baguio.
Sure. Very well. Yes, I'll just leave my email and the chat so we could continue yeah, sharing information on the topic. So yes, I'm also aware of the Corditex project of UP Baguio. So congratulations also on your developments on that part. Thank you.
Okay, so I have a few questions on YouTube.
Thank you.
This one comes from Ramil Arshosa. So there are several questions. So the first one is, aside from pineapple and bamboos, a source of textiles and fibers, are there any studies about ornamental plants as the source for textile fiber?
Yes, Sansevieria has been used. The Sansevieria species have been extensively used, and this is actually because it's available, and the students, when they search textile fiber, lumalabas Sansevieria. I was able to see that for myself. Kasi sa Google, unang lumalabas si Sansevieria. But yes, the Sansevieria family does have textile potential. Yucca also has textile potential. So, ang kailangan na lang sigurong i-balance doon is yung kaniyang application for horticulture. Baka mas mahal siya na nasa horticulture than you extract it for textile. So, yun na lang siguro. But otherwise, yeah, the ornamentals are also very interesting source of textile fiber.
Okay, there's a follow-up. What particular process would you need to determine the originality of the tinalak weaving? Is it
We,
radiation?
we don't know. It's just the rules of origin thing. If we know where it came from, then we could authenticate. But technically, we don't have. That's what we are trying to move very fast now on, because we need to protect at least those that are woven by our our artisans. So we are working on the part where we have the markings, but we are also trying to profile them properly so that we know the movement. We can track the movement of the fabrics from the ground. If we know that this community is producing this much, then we know that most likely it came from there. Another approach is that we also have profiled yung kanilang patterns. So there's already some families of patterns that we could already attribute to some communities. So we are doing that with a non-government organization, and yeah, hopefully we will be able to do that as well in the near future.
Okay, still, Ramil, can natural dyes be applied to basketry weaving?
Yes, sure. For as long
And
as it's natural material.
okay, so his final note would be he's working with Teduray and Banuvo Erumanin in central Mindanao, particularly on eyepiece basketry weaving. So is it possible that natural dyes can be applicable in Nito bamboo?
Yes, Nito. Very well for Nito. Nito just has to be processed kasi ang Nito has already an innate sheen on it. So medyo yung waxy side would not enable it to absorb the dyes, but in processing and further putting some finishing afterwards, you could definitely dye Nito.
Okay, and then we have some comments from Tito Aliga. Key paradigms: lock in the benefit with the host community, focusing on one town, one product. Number two would be research productivity, quick turn from lab to market. And number three would be design and fabricate your own equipment. So,
Yeah, sure.
mabuhay ang Tela Pilipinas.
Yeah. Okay, I just like to acknowledge lang, of course, our members, and the director from our Board of Investment, Director Aries, thank you for joining us. Also, Ms. Tambaga, Director, also Ms. Tambaga from the DMFSU, and I think I also saw here some people from the De La Salle College of St. Benil. They have a fashion school there. So thank you very much for joining.
So I think, okay, that was a
Thank
very
you.
interesting presentation. Unfortunately, I wanted to ask something, but he had to leave.
No problem. We'll keep in touch. Yeah.
For the other meeting. So,
Yeah.
are there any other questions from our audience? Okay. Yeah, I think it was very interesting, and actually the 1 hour was not enough. But thank you for giving us your email address, and people will get in touch with you. Julius, will it be okay for me to share your presentation with those who attended this meeting?
Sure.
I'll
Yeah.
just turn it into a PDF,
PDF, yes.
and
Yeah.
I'll be
Thank
sharing
you.
it with them.
Sure.
Before I ask you to say your final words, I'd like to invite everyone to the other forum. Okay, hold on. So far, I only have the QR code here. I did not have enough time to. So let me just share my screen to show you the QR code, and hopefully, if you click on the code, okay, can you? Maybe I should test it out.
Uh,
Okay, so it should take you to the next event that we are having, which is the PAASE Fireside Chat. So I will also try to input here the ID number for the Zoom link. Okay, so I hope that's working. Okay, so sige. Julius, any other final words for our audience?
yeah, just thank you very much for the interest. I think there are just a handful of us who might understand textiles as a science, or as a science, as a research field. Maybe some more who understands the garment side. But definitely all of us wears one. So this is not an exception. So I think the self-reliance posture is something that we have realized during this pandemic. We must be able, at the very least, to satisfy our basic needs, and that is to clothe ourselves and protect ourselves. And hopefully, we can do it with our own local textile development. And we ended with that. Please wear Filipino. Thank you very much.
Thank you very much, Julius. I actually have several other questions for you. Thank you so much.
Thank you. Thank you very much po for staying. Salamat po. Maraming salamat. We'll keep in touch.
All right. Thank you, guys. And I hope you can attend